Hey Defenders, let's install the back half of our Wazuh architecture, Elasticsearch, Kibana, and Filebeat. Filebeat is what is responsible for shipping our alerts.json, the file that we were tailing in the previous video, to Elasticsearch. Elasticsearch will store and query these logs, and Kibana is the web UI that we will use to view and make query calls to Elasticsearch. This may seem like a lot right now, so let's dive in and begin to wrap our head around the final pieces to our full Wazuh deployment. But first, time for my shameless plug. If you want to learn more about our company, head on over to opensecure.co. If you would like to hire us for a project, select the Hire Us button at the top of this video. To see firsthand the power of open source technology, take advantage of our interactive demo. Select the demo button and start exploring. Now let's get back to the video. Alright, so let's go ahead and get into configuring our last portion of our Wazuh architecture, our Elasticsearch, Kibana, and Filebeat. So those will all run as three separate services. So Elasticsearch will run on our Elk server here, and this is what you could think of like a database. It'll store the JSON logs that are sent via the Wazuh manager via Filebeat. So you can think of Elasticsearch as a database and search engine to not only store but enable us to filter on different variables within our logs and within our metadata, which you'll see here in a little bit. Also running on the Elk server here is Kibana. Kibana will also run as a separate service and will query, is our web user interface that will query Elasticsearch for us. So within Kibana, if I say, hey, I want to filter on this source IP, give me all of the alerts that have been triggered by this source IP, we'll implement that within Kibana, and Kibana will query the Elasticsearch service that's running on the same server. And the last portion of this deployment will be Filebeat, and Filebeat will actually run on the Wazuh manager. And Filebeat it also runs as a separate service from the Wazuh manager service and is the log shipper. So it takes the logs that we're shipping from the Wazuh manager and is responsible for shipping them to Elasticsearch. And from Elasticsearch, Elasticsearch stores them, and then we use Kibana to query them. So these three pieces are the last services that we need to implement and deploy and configure before we have a totally working Wazuh environment, let's say. So let's go ahead and jump into it. Jumping back to the installation guide here within Wazuh, I like to go to the more installation alternatives and deploy Wazuh with the Elasticsearch basic license. This will, going forward in some of the more advanced videos later down the line with the more advanced and more secure production style deployment, we'll get into certificates, and that's where we'll go to a more advanced installation. But for now, I like to install Elastic with just the basic license. Again, we also have the different deployments. We can do an all-in-one or a distributed, and it follows the same as the Wazuh manager. We can cluster, Wazuh managers to load balance and also have redundancy. We can also do that with Elasticsearch, and especially in a production environment that is 100% the way to go. You can get a lot better performance clustering, 4 Elasticsearch servers together to basically serve as one node. So kind of what that means is, say we spin up 2 more Elasticsearch servers. So our Wazuh manager will pump to our main one, and we'll also pump to our secondary, and then as well as to our third. And what's really powerful about Elasticsearch, and they do a great job of Elasticsearch clustering, is able to load balance not only when it's queried by Kibana to retrieve results, but also storage. So it'll equally store, say I have, let's say for math simplicity, I'll just do a fourth here. So let's say I have 100 gigs of data that I'm sending from my Wazuh manager that needs to be stored. Well, Elasticsearch will store 25 gigs on the first one, 25 gigs on the second, 25 on the third, and 25 on the fourth. And Elasticsearch does that out of the box for us, and is very sophisticated in that manner, and it's come a long way, and it's able to not only equally store our logs for us, but is quick at retrieving and presenting them to us within Kibana. Now, one thing don't get confused about is our Kibana instance will run only on one server. So we're going to spin it up on our Elasticsearch server here, but so this will be the same server, but you can think of it, I'll kind of just throw it off to the side here, and this is still one server. It'll run on him, but only one Kibana instance is required. So Kibana will query this guy, Kibana will query this guy down here, and so on for the other two as well. But that'll get more clear whenever we look at the configuration file for Kibana. So, but Kibana will only deploy once. You can also do Kibana like kind of cross clustering, but that's more advanced, and we'll also get into that later. But for now, in this demo and this purpose, we are going to just deploy our one server that'll run Elasticsearch and Kibana, and then Filebeat will install on the Wazuh manager as well, and we'll see that here in a sec. And now Elasticsearch is actually handled by Elastic. So these guys are responsible for the new features, bug fixes, whatever the case may be. They're responsible for all work on Elasticsearch, Kibana, and Filebeat. So these guys are also, this is also an open source tool, and Wazuh takes advantage of this open source tool, Elastic, to store and present the logs to us in a much more user-friendly way. There's a few other tools you can use to pump Wazuh logs to. You can use like Splunk, for example, is one of Elastic's kind of equals, I guess you could think of that. They work on doing the same thing that Elastic is doing, but Wazuh has taken advantage of Elasticsearch and Kibana, and it's pretty powerful, and we'll get into that here in a sec. So let's go into our deployment. So first I want to install Elasticsearch, and then I'll worry about installing Filebeat second onto the Wazuh manager. And we'll get into that here in a sec. So go ahead and throw this off to the side. We have our server set up. Let me go ahead and get the repo added here. And then we'll also just run a simple command again. Just a yum install. And it looks like they provide a configuration file for us. Let me see what this looks like. I haven't actually looked at this. Elasticsearch will have its own kind of pre-populated file. So if we go into etc Elasticsearch, elasticsearch.yaml will be the configuration file that where we will configure our Elasticsearch cluster and what we have available to it. So I'll just go ahead and use the default that they provided here. There's a few things we want to uncomment and make sure of. So cluster name, this can be whatever you want. For this purpose, I'll just do Wazuh demo, but maybe you have multiple clusters within a data center that maybe one of them you're writing Wazuh logs to, maybe another you're writing like firewall logs to, or something like that. You can make this name unique, so you know what cluster you are working on. Node name will also uncomment, and this is in our instance, this name can also be unique. It can't be a duplicate of another node though. So since I only have one node in this cluster, node 1 is fine. If I were to add another Elasticsearch cluster, so if we go back to our diagram here, or sorry, Elasticsearch node, not cluster. So I want to add another node that I want to also pump Wazuh logs to. I would install Elasticsearch and give that one like a node 2 name or whatever naming convention you're currently using. So I'll leave that at node 1. Node attribute we don't have to worry about. The path data and path log. So path data is the directory where Elasticsearch will write its storage of our alerts.json file that we receive from the Wazuh manager. And this can be any directory. It doesn't matter. Elasticsearch for disk highly recommends using SSDs due to speed, mostly. Elasticsearch consumes a lot of memory on the box as well that it's running on, so they advocate, depending on the amount of data that you're ingesting from your Wazuh manager, bumping up the amount of memory you have allocated to your server up to 64 gigs. They say that they don't see significant increase of allocating more than 64 gigs of memory to your Elasticsearch server. What they recommend is, instead of bumping up to 100 gigs or something of RAM, what they recommend is spinning up another node. So it's spinning up another Elasticsearch node and allocating 64 gigs to that node as well. Like I said, Elasticsearch is really good about working together. So instead of making one like super server, they recommend having a bunch of smaller servers that work together to balance the load. And they also, like I just mentioned, recommend SSDs. You can also do file shares, such as NFS mounts. They don't advocate that. Of course, you're having to pass logs across the wire, right? So there's in we're going to be pumping a lot of logs to Elasticsearch. So depending on network bandwidth, that can have a highly negative impact as well if we're having to write hundreds of gigs of data a day to our NFS servers, especially if those are having to maybe traverse a different VLAN. And you're trying to cross like a 1 gig firewall, depending on how your network is configured, that can have a negative impact. And of course, you're also relying on your network to always be up in order to store logs. So for example, if our network went down for 30 minutes, Elasticsearch isn't able to write the logs that it's receiving from its manager to its storage point for data where it needs to store this data. So that'll back up Elasticsearch and can result in you missing logs. So they recommend SSDs. Hard disk is an option you can take as well. SSDs get expensive as you look to purchase more storage space. So you just have to balance that out within your organization. But this can also be whatever directory you want. So I could mount a path.data. I could mount a var. Say I created a var, open secure, please subscribe directory where I wanted to write all my data to. I could easily do that here too. So that can be changed, but by default, this is the value. This is the directory that we point to here. This path.logs is where Elasticsearch writes its debugging and troubleshooting logs to. So the service as a whole, if a node goes down for some reason or Elasticsearch can't start for some reason, that's where this will be logged here. So any debugging purposes you can do there. Bootstrap memory lock I like to enable. So another file here we'll look at in a sec is you can tell Elasticsearch how much memory to lock, or you can tell your server, actually your operating system, how much memory you want to allocate and lock only for Elasticsearch. Like I mentioned, Elasticsearch is memory intensive, so it's a good idea to lock the Elasticsearch process to an allocated amount of memory, depending on how much you have on your server. Network hosts, since we're using just a local host, that's fine. Let me actually go ahead and make this the IP address that we have for this guy. So this will be the IP address, your network interface that your Elasticsearch binds to. This HTTP port is what we'll use. This will be the port that we point to that Filebeat will write to. So that'll get more obvious here in a sec. We have some seed hosts. You don't really need to worry about this. The master nodes you can worry about. So master being, there's different roles a node within an Elasticsearch cluster can take. In our case, it'll be performing the master, the data, and the ingest roles, where if you have a more clustered environment, you could set, or a multi-noded cluster environment, you could have, you know, 2 of these run the master role while 3 others are performing data ingestion. And the master role is just kind of like a housekeeping kind of thing, making sure load balancing is happening appropriately, making sure your other nodes are up and alive and participating in the cluster. And so you can specify what you want here, and this will match your name of your node. So if you remember above, we set our node name, we just left it at the default at node 1. So if you were to change that to a unique value, you would also want to change that here. And since we only have 1 node within our cluster, I'll go ahead and erase the second one that they have set. And all right, now we were almost ready to start Elasticsearch and run our kind of basic health checks and make sure that it's running properly. So I mentioned that file that we can modify to allocate memory to. And that's under still Etsy Elasticsearch JVM options is where that's set. And the ones we'll worry about here are the amount of heap space that we'll allocate to Elasticsearch. So here it's set to 1 gig. A good practice to do is to just check how much memory you have allocated to the box. So I have 4 gigs allocated. So Elasticsearch recommends allocating half of your available memory to Elasticsearch. So a 64 gigs of memory you have allocated to a box, you know, that'd be 32. And you know, if you have an 8 gig RAM, you allocate 4. So that's what they allocate here. And so here we'll tell ours to use 2 gigs of memory. We'll go ahead and save that, and we can go ahead and enable and start Elasticsearch. Let's go ahead and enable it, and we'll go ahead and start. This will take a few seconds to spin up, and we'll see if it spins up clean or not, or if we need to perhaps do some troubleshooting. And it looks like we do. So let's see what's going on here. Memory locking process, but memory is not locked. Okay, so it looks like the locking of the memory failed for us. Let's do a quick Google search and see, because there may be some kernel parameters we can set. All right, so let's look to allow this securitylimits.conf file. Let's take a look at this guy here. Let's go ahead and add these values here. Let's also look at our Elasticsearch service. Well, let's go ahead and restart and see if that was actually what we were missing. Right, looks like we're still running into that same issue. So let's look at the actual service itself. And let's set this limit memlock equal to infinity. Let's see, does that already exist? Does not, so I'll go ahead and specify that here. Let's do a daemon reload. And I'm trying to restart it. All right, and that looks to have been the trick there. So we needed to add in our etsysecuritylimits.conf, we needed to basically say the Elasticsearch service can run this memlock, and then we also set the memlock equal to infinity within the configuration of the actual Elasticsearch service. So when we do a systemctl restart Elasticsearch, it is looking within this directory here to run that, and we made that change of limit memlock equal to infinity there. And it looks like we are now running in a much healthier way. So as I mentioned, it should be listening on 9200. So Elasticsearch is listening on port 9200 for connections, so that's good. This 9300 is used for also by Elasticsearch and is used for cluster communication. So Elasticsearch to Elasticsearch, and let me go back to our diagram here. We'll talk on 9300. So if I had another cluster here, or another node here, sorry, I keep messing that up. That will talk on port 9300, where our Wazuh manager and the Filebeat service in particular will send logs to Elasticsearch on port 9200. So now we can go ahead and get into that, deploying that as well. And I have my manager here set up on the side. Throw him over. We'll go back to our Wazuh docs here, and we're going to look for the Filebeat service. So we'll install Filebeat. So the repo, I believe, should be here already. We'll find out. It is not. So let's go ahead and add it's actually bundled with the Elasticsearch repo. So that's why it didn't exist yet. That we had the Wazuh's repo. We need to add Elasticsearch. Sorry, that's the Wazuh one. Here's Elasticsearch. All right, now we can run that again, and that'll go ahead and install for us. All right, and so there's a few more things we need to do for Filebeat. Let's go ahead and we can actually copy over their Filebeat config that they have. So we can go ahead and copy that over. Let's go ahead and look at that, because there will be a change that we need to make. So like Elasticsearch, Filebeat also has it's under etc Filebeat, filebeat.yaml that we'll use for config. I really start needing to install Nano before I start these videos. Okay, and really the only change we don't have a password yet, because that'll be a more advanced video down the road. We also will be using HTTP for now, not HTTPS. So I will comment out these guys, and this will in our more advanced videos, this will be encrypting our logs as they go across the wire. So this is definitely something I heavily advocate in doing. We'll generate self-signed certs. If you also have your own CA and your organization implements or doesn't allow self-signed certs within its own internal networks, you can also get them signed by CA, but we'll get into that at a later date. So we're saying that we're sending logs over HTTP. Of course, in our demo deployment here, we are sending logs across the internet, and especially in HTTP is a big no-no. So if this were outside of demo purposes, this would be a huge flag. But we'll also comment out the password, and what we need to do is specify our host. So we will use the IP address of our Elasticsearch server, which will be this guy here. And you see we are pointing to port 9200 to use there. So we can save that, and just right off the bat to test, we can do a Filebeat test output, and that'll test to see if it can connect to the Elasticsearch service. And sure enough, it can. It's writing, it's doing an HTTP request, like we just changed, and then we're pointing to our IP that's running Elasticsearch, and we get a OKs across the board. You see, we get this warning here for a non-secure connection, basically saying, hey, you're not implementing TLS, so your data is not encrypted across the wire here. Now, Filebeat also has a few templates that we'll upload that Wazuh generates for us and keeps track of for us. So we'll kind of get into that a little later, but templates being, this value within my log is my destination IP. This one is my source IP. So with these templates, you can customize the values that Filebeat will assign to your kind of metadata as it pushes it to Elasticsearch. And that'll be a little more obvious here when we look into it. But thankfully, it's just a few commands on our end. We download the Wazuh template.json, and then that Elasticsearch host within their GitHub, and we just set it to we copy it to our etc Filebeat directory, and then we had to change permissions, change the modification of it, so that Filebeat can actually read it, and then we'll also download the Wazuh module here that Filebeat will use. Filebeat also has various modules depending on what logs you're shipping over. So Suricata, Cisco, Apache, whatever server that you're sending logs from, Filebeat has a ton of modules that come pre-bundled with it that you can just quickly enable to make our lives a lot easier. But Wazuh provides their own module for Filebeat, so we copy that here. And then we've already done that. And now we should be okay to go. So we can run a reload here. And we'll go ahead and enable. And then we will go ahead and start Filebeat. And if we run a status on this guy, we should see. And sure enough, we see connection to Elasticsearch established. So we are now starting to pump logs to our Elasticsearch server. So kind of reviewing that again, we stood up Elasticsearch, which was on the server alone. And next we stood up Filebeat, which is actually on our Wazuh manager. And if you remember from our last video, we were tailing the var osec log alerts.json file, right? And this is an eyesore, right? And you don't want to. This is the file that Wazuh outputs its alerts to, that it receives from its agents. But we don't want to be responsible for just constantly watching and tailing this file the whole time and then hoping that we see some type of alert. So what Filebeat is doing is taking this file and sending it to Elasticsearch so that we can then visualize it within Kibana. We can also store it reliably. And all right, so if we kind of look under the hood at Filebeat and kind of, you may ask, well, how is it taking the alerts .json file and actually shipping it over to Elasticsearch? And so what we have here is what Wazuh has done for us, which is great, makes our lives easier. We just have a few point and click commands. But how it's actually happening under the hood is we have a few configurations here that come set. So if I go into Filebeat, and I mentioned the mappings before. So if we look at the Wazuh template JSON, you can see Wazuh configures these mappings for us, which is great because this would be a pain to do, right? And we're telling based on the value, I guess, what type it is. So it could be a keyword. Here we see a date. It could be a string value. It could be text. And so that's used by Elasticsearch and Kibana under the hood to enable us to run our queries off of. You can get really more advanced with it. Wazuh has done that for us in terms of mapping. Now we also, as we've looked, this is our log file that we are shipping over to Elasticsearch. And you may ask, well, how does Filebeat know to ship this over? So if we go into our user share Filebeat directory, we'll come across a module directory. So we'll go ahead and go into that. If we list these out, here you can see all of the pre-bundled modules, so that make our life a lot easier. If you were to just install Filebeat right off the rip, you could say, say you're collecting silence logs or you want to forward F5 logs. You just do a Filebeat enable module and then point to your particular module, and that's Elasticsearch has these pre-settings already configured for you, so you can send those over. In our case, we're looking at our Wazuh module. So if we list this, we go into alerts, we see a manifest.yaml. If we open this guy up, we see our paths of logs that we're sending. So, you may ask, well, how does Filebeat know to send this alerts.json? Well, and that's under the hood, that's what we're doing with this file here. So if I wanted to say I had another file path file that I wanted to send, I'd say var open secure please subscribe .json. Let's say I wanted to also forward this, I would specify that here. So, but that's for those curious of nature who are curious how it's working under the hood. That's how that's done there. So now we're almost done with our deployment. Lastly, we need to install Kibana, which will be our web UI, and that will also be done on the Elasticsearch server. So now we are completely done with our Wazuh manager. We have the Wazuh manager service installed, and we also have Filebeat installed. So now our last missing piece here is Kibana. We've also made sure that Filebeat is able to connect to our Elasticsearch with this command here. We also saw it within the logs, but let's now finish our Kibana. And Kibana is also managed by Elastic. So the Elasticsearch repo that we copied over takes care of that. So we can just run a quick command here. To start installing that. And Wazuh also has its own application within Kibana, which we'll go ahead and configure, and you'll see kind of what that means here in a sec once we get the web UI stood up. All right, so Kibana is installed. Let's go ahead and get the configuration file copied over. We don't need to worry about that or that yet. And so let's go ahead, before we finish configuring Kibana, let's go ahead and run the rest of these to get the app installed, as well as some ownership of some directories here that we need to change. So we'll go ahead and cd, and so we went ahead and copied the Kibana app plugin. We won't worry about that for now for demo purposes. And now let's go ahead and let's look at the Kibana configuration file. So like Elasticsearch and Filebeat, Kibana also has its own kibana.yaml. And here we have a few options. So this will be the host that we are, the interface that we are running the Kibana service on. So I'll go ahead and set this to my IP address of the interface that I will be using. So of course your O.O.O is just localhost, but since I'll be hitting it from the internet, I'm just gonna hard specify it here. We then also have our Elasticsearch host, and so that'll also be the same box. And you see, like Filebeat, we also point to 9200. So Elasticsearch is running on port 9200 and also 9300, but like I mentioned before, 9300 is only used by other nodes within the cluster. And we are only using HTTP, so I'll go ahead and set that. We're not doing any SSL, so I'll go ahead and comment out all this. Like I said, this will all come in a more advanced video later. XPack and all that will also be discussed as well. So all we really need to do is make change our host here. If you want to change your port, you can do that here as well. The port that you'll use to connect to Kibana. So actually, since I'm coming in over HTTP, I'll just do port 80 here. And we'll go ahead and save that. And let's go ahead and run a reload. And we will start Kibana. All right, so we got that started. Let's go ahead and Kibana will take a little bit to start up. So let's go ahead and just run a watch command on the status of Kibana, and we should see some output here. We'll see it connect to Elasticsearch, and we'll know when we're ready to connect. And all right, it looks like it doesn't like something here. Permission denied on port 80 here. Okay, so let's do some troubleshooting here. Go ahead and stop Kibana. Let's make sure nothing else is listening on that port. Oh, and now Elasticsearch isn't running, it seems to be. Elasticsearch is not. So let me stop Elasticsearch, and maybe I've allocated, I only have a few gigs of memory on this demo box. So Kibana is also going to use memory to run. So let me draw back the Elasticsearch. And we can also kind of take this as a learning opportunity too. If I do a test output here, we see connection refused. So this is a great command to quickly test if your Filebeat is actually able to connect to Elasticsearch. Here the service isn't running, so of course we get a connection refused. So let me go back into my JVM options here, and we'll go back to just 1 gig instead of 2. Let's go ahead and start this up. And looks like that started back up for us. Okay, that looks good. Doesn't look like anything's running on port 80, so we should be able to use that. Firewall D is not running, so that's good. Let me actually just change this to 8080 just to be safe. And that is our IP address, I believe. Yeah, that looks good. All right, let's stop Kibana again and restart. And let's go ahead and watch and see if that gives us any better luck. All right, so it does look like this is starting up a little healthier now. So that's good. So it looks like we were, Kibana possibly didn't have enough memory to run because Elasticsearch was taking it. So that's where setting the amount of memory you allocate towards Elasticsearch, benefits, but could also, if you over allocate, could hurt other services that you rely on running on the box, and in this case, Kibana. All right, so that looks to be starting up a little better. So let's see. Let's run a netstat, and it looks like it's listening on port 8080, like we said. So let's also see if we can connect to this guy. See what we get back. Okay, so we're able to connect. We're getting a Kibana server is not ready yet. That's fine. I do see this socket hang up. I'm trying to see. Oh, looks like something happened there. Okay, yeah, it looks like it got past that. So we should be moving along here. Okay, and here we go. So we are now loading into Kibana. And let's go ahead and be cool and configure a dark mode, because you're not in IT if you're not working in dark mode. So I'll go ahead and save that, and we're coming into dark mode. Cool. And so now if we go back to home here, we are now in Kibana. So this is our web UI that we'll use to view our logs that we receive from Wazuh, filter on them, and interact with our Elasticsearch instance. So if we, so right off the bat, you can see the Wazuh app here. We'll get into that here in a sec. But if I go into stack monitoring, let me set up self-monitoring, and I'll turn it on. So this will give us monitoring data on our Elasticsearch. So, as I said, we have within our Kibana YAML here, we've pointed to our Elasticsearch server, right? So if I had more than one nodes within my cluster, I think this syntax is probably off, but just for these quick little demo purposes, say it's now a .97, so I have 2 nodes within my cluster. I would add that here. So I'm telling Kibana, hey, you're going to query Elasticsearch running on these 2 servers here. So that's how we handle that. And if I look at my nodes here, I see my 1 node that's running Elasticsearch, and you also get some resource data on that as well. And as you can see, it's starting to write indexes, and this is what stores our Wazuh alerts, right? So we see our index Wazuh alerts here, and this will be rolled over or rotated every day. So tomorrow it will be a 01.26, so January 26th. And we can see data has already started to populate within that as well. So if we go back actually to Elasticsearch, and remember how we talked about where we're storing the logs within our data logs, right? So if we go into this directory here, ls that, so we see nodes, ls, we'll go into 0. I don't know why it follows this directory structure, but it does. So if we go into cd, if we cd into indices, it doesn't really make sense. Elasticsearch, I guess, generates, maybe this is a hash of some sort, I don't know. But these indices store data that relates to our index for today. And index for today, you can think of like today's alerts, is pretty much what that means. So we can see Kibana is able to interact with our Elasticsearch node. And so before we get into Wazuh, let's just quickly make sure that we are receiving alerts. So if I go to my Discover tab here, we will be able to filter on an index pattern. That index pattern matches what you previously just saw. So all of our alerts are being pumped into our Wazuh-alerts index. So if I filter on this guy, and let's see if we have any in the last hour, and we do. So here we can see our logs starting to come in. Let's parse out kind of the fail logged here, or the full log, sorry. Let me stop that. This is just auto refreshing. I want to stop that. So as you can see, because my box is the internet's allowed to hit it, I have all these bots trying to log into my server here. Of course, in a actual deployment, you want to cut off access from the internet, but here we can see how crucial the host intrusion detection system is, right? Here we can see everyone trying to log in. We also get the IP address that they're coming from, the country that they're coming from. That'd be region, country that they're coming from. And so you get a lot of great metadata around this. And these are, if you remember our last video, we were looking at the Wazuh rules, and that's what this group of guys are doing here. And we'll get a lot more into that here later down the road. But as of now, this still isn't. This is pretty. This is getting better, right? This is a little more user friendly. We're not just tailing our alerts.json. But in the next video, we will get into the Wazuh app, which we installed via the Kibana plugin installation there as part of installing Kibana. And we will get more into depth into how to kind of better recognize these attacks and how to get more organized and how to manage Wazuh even better. And as always, let me know down below what you liked or disliked about this video, any errors I may have made, as well as recommendations for other open source tools you think I should explore.